The next two special segments we're going to talk about are the median and the altitude in a triangle. A median is a segment that connects a vertex to the opposite midpoint. Okay, so this is an example of a median. It goes from a vertex to the midpoint. So if this is a midpoint, I know these two pieces are congruent. An altitude is a segment that's perpendicular to a side and goes through the opposite vertex. So I've actually got two altitudes on here. You notice a median is always going to be inside the triangle. Okay, so if I draw the other ones in, it'd be from this vertex to this midpoint, this vertex to that midpoint. It's got to be in the interior. Altitudes can be inside or outside the triangle. So from this vertex, perpendicular to this side, goes through the inside. But from this vertex, if I want to be perpendicular to the opposite side, I would almost have to extend that side to see where the perpendicular line would meet. So I get this altitude that's outside of the triangle. And just like we did with perpendicular bisectors and angle bisectors, if we put all three of these on our triangle, we're going to get a special type of center for our triangle. Okay, so if we do all the medians, we're going to get the centroid of our triangle, which is probably the most useful center. It's more what we would think of as the actual center of the triangle. It works as a balance point, actually. So if I had a real triangle and I found the centroid of it, I could balance it on, the head of my pencil or the head of a pin, and it would balance perfectly. So in order to find this, what we're going to do is we're going to need to find the midpoint of each side. Okay, and the way to find the midpoint is the same as bisecting each side. So we're going to use our same tools, and we're going to bisect each side. The only thing we're concerned with is finding the midpoint. So I'm going to try not to make too much of a mess here. So I'm just going to use 3 circles that are all the same size from each vertex. Okay, actually I'm going to change the color of them so we can pick them out more readily. Let's make this one red. Oops, I don't want to fill it. No fill. I just want the line to be red. We'll make this one green. So if I find the intersection of the red and the blue, that'll give me the midpoint of this side. So I can mark that. Here's that midpoint. If I find the intersection of the green and the red, okay, that'll give me the midpoint of this other side. And if I find the intersection of the blue and green, that will be our last midpoint. That's pretty close. No, I want it to be a little closer. There's my midpoints. Now all I need to do is connect them to the opposite vertex. Put my ruler on there and then turn it up to the vertex. I can draw in my median. There's one median. There, right there. Go up to the other vertex. I can draw my next median. And then finally this vertex to that midpoint. I'll give me my last median. Okay, and they're all concurrent. Okay, they're all meeting in one point. So that right there is my centroid, right where they all meet. Okay, so this is a construction that's in your packet as well. And if I were to cut this out, I could balance this triangle right on that point. The orthocenter is the point of concurrency of all the altitudes. So if I'm going to construct all my altitudes, okay, I'm going to have to extend some of these lines. Like I can already tell that this one is going to be close, so it's going to be off the line somewhere, so I'm going to extend that. Which other one might not make it? Let's see. This one's perpendicular to that side. This one will make it, because it's got to be perpendicular here, and this one has to be perpendicular to this, so I might need to extend this other side as well. Okay. So now we'll start constructing them. So if you remember the construction for, we want a line that's perpendicular. So let's see, let's go through it from this vertex first. I want to go through this point and be perpendicular to this side. So I need a circle that's going to touch that side twice. Okay, so it looks like I need to extend that line a little bit further. Okay, and then I'm going to bisect that. So we go from this point where it touches. Okay, and it'll touch there, and then I just need to know where it is down here. And then from this point also. And then I can connect those. So we'll do all our altitudes in red so we can pick them apart here. There's one altitude. Okay, so that means this is a 90-degree angle here. Yep, okay. Then we'll do the next one. So I need another circle. Let's do this one. So from this vertex, I want to touch this side twice. So I'm going to make a little bit smaller circle because I don't need quite as much. Okay, now I've got my 2 points and I bisect. So I know it's going to touch that vertex. I just need to know where it's crossing down here. Okay, you can confirm that it touches your vertex right there. Okay, so I'll connect these. To get my next altitude. Okay, and I want to go until it touches this other one. I know they're going to touch down here because this one's veering off too far that way. And then I'll do my final altitude, which will go from this vertex down to this opposite side. So let's see how wide I need to go to intersect that twice. There we go. Got that one, and over here. So if I connect this, well, I almost didn't make it, but it did. Oh, actually here. To there, that'll be my last altitude, and I can already tell that they're all going to meet in the same place, so that reassures me that I did it right. Okay, this spot right here where they all meet is called the Orthocenter. There's no special properties for the Orthocenter, actually. It doesn't do anything special. It's not a balance point. It doesn't set up any congruent parts. It's just the other center that we need to know about. There is a special property of the centroid besides the fact that it's a balance point. And I'll leave that up to you to discover on your packet, but it does set up some constant ratios within these links and segments and things like that. So that concludes the discussion on medians, altitudes, the centroid, and the orthocenter.